you have a function, and as you can see, this is a quadratic function written in vertex form, right? Recall, what's the vertex form? F of x equals to a times x minus h squared plus k, and h comma k is the vertex in that case, right? So what's the vertex of this function? What's h? Compare that with this. H is 2, k is 3, so 2 comma 3 is the vertex. And if you knew that, then it would be very easy to draw this graph, which is if you see it's 2, and then here's 3, and here's the vertex, and then you have a parabola left and right, except that because our domain is 2 to infinity, it's only, the graph is just on this side. Now, there's a reason why I did not put this side. Because if I really had this one, then it would fail the horizontal line test. What is the horizontal line test for?
So one input.
Yeah, so horizontal line test tells you if it's a one-to-one function. And if it's not a one-to-one function, then you cannot have an inverse function. Because the inverse, okay, so let's see. To explain that, I have to go back and explain this procedure of finding the inverse function. Okay, to find the inverse function, what do you exchange? What? X and y are interchanged to get the inverse function, right? So if you switch these two to get the inverse function, what happens to the graph? If x and y is changed, what happens to the graph? It flips over what? I'm flipping over where? What's this? What's the center of the axis as I flip over? I'm flipping over this line here, right? What is this line? That line is called y equal to x. Right? So finding the inverse function is equivalent to flipping over the diagonal y equals to x. And what that results in is, if you have something that does not pass the horizontal line test, if the horizontal line passes the graph twice, and then if you flip over the diagonal, that horizontal line becomes a vertical line. So what horizontal line test really is, it's a vertical line test done to the flipped one. In other words, you're testing the inverse function to see if it's a function or not. Okay? If some function fails the horizontal line test, it's going to fail the vertical line test, which means it fails to be a function. And that's why failing the horizontal line test means f inverse of x cannot be defined, or at least f inverse of x will not be a function. Get it? Okay. Right. So that's a very important point. That's why I have this set up as f of x should be 2 or greater. And because of that comment that I made, you can actually draw the graph even before finding the f inverse of x. Because all you have to do is to just take this line and flip this over there. Okay, let's see how that works. First, this point 2, 3, if you flip over the diagonal, what will be that coordinate? Flipping over diagonal is switching x and y, right? So what's the new coordinate that this will go to? 3, 2, right? So it's here's 3, here's 2, and this is the new point. So that's the new vertex. And it has to be symmetric here. So if this thing goes closer, and this should also go closer. If it goes further away from this line, it has to go further away from this line. So you end up with this curve. So that's the graph of the inverse. Okay? Yeah, I just realized it. Okay, so the answer for the graph would be something like this. You have 3, 2, and it will be half a parabola from this. So that's the answer for the graph. And how do you obtain this? You flip the original graph over the y equal to x. Okay, for the actual formula, what do you do? What are the steps? I think we did several examples. What's the first thing we do? How do you find f inverse? Yep. Flip x and y. That's the first step, right? Except that I don't have y here. So what do I do? This should be y, right? So we first write y. And we flip x and y. So y becomes x becomes y. So that's what you get after flipping x and y. Okay. That's the first step. What's the second step?
Subtract 3.
Yeah, so in other words, you're trying to solve for y, right? That's the second step. You solve for y. How do you solve for y? Well, you're trying to isolate y, right? So you look at all of the operations done to y and take out the last thing that was done. So 3 was then done the last, so we subtract 3 both sides. Then 1/2, you multiply that, so it's 2x minus 6. Multiplying by 2 gives you 2x minus 6. Now what? How do you get rid of this 2? Take the square root. Now you have to be careful here. When you take the square root, it's either plus or minus, and you have to figure out which one it should be. But because we have the graph pointing upwards like that, it should be the positive one. If it was minus, then it would be giving you something that goes like that, okay? Because if you solve for 2, look at this. Y, if you add 2 now, it'll be 2 plus square root of 2x minus 6, right? So look, would y be more than 2 or less than 2? Y value would be more than 2 or less than 2? More, because you're adding something positive, right? Square root is positive, right? So it's y equals 2 plus something positive, and therefore it agrees with this graph where it's 2 or more. So that's what you get. All right, I should also have said the domain and range. So although I didn't ask for domain and range, let me just finish this. So the answer to the question is f inverse of x, therefore, is 2 plus square root of 2x minus 6. And the graph would be this. So that's all for the answer for the question. But let me address 2 more things. What are the domain and range? What's the domain and range of the original function? Domain, as written here, is 2 to infinity. What would be the range? To answer that, you have to go back to the graph. That's the graph, right? So what's the lowest point of the graph? 3. 3 is the lowest. And goes to infinity, right? So what's the range? 3 up to infinity. Right? Okay, so those are the domain and range of the original function. What's the domain and range of the f inverse?
2.
These two will be switched, right? Domain and range gets switched because you're switching x and y. The domain and range of the inverse function is the domain and range of the original function switched. Okay. So the domain for this is 3 to infinity, and then the range would be 2 to infinity. So that's a very important thing to know, that domain and range switches when you find the inverse function.